Hello, everyone. This is Anji Seberino. I'm a Mathcad Technical Field Specialist here at PTC. I work closely with our customers as well as with our Mathcad product team. In this session, we'll be talking about how making the choice to use Mathcad and Excel together optimizes your engineering calculation workstream to give you the best of both worlds. Before we get started on the topic of Mathcad and Excel together, I thought it would be helpful to provide a brief background on how Excel became so pervasive within the engineering calculation space. Excel was originally designed for data organization and data manipulation. Using a structure of rows and columns, it was created with a focus on accounting and finance purposes. Over time, Excel evolved. More math functions were added to it, more features were added to it, but it always stayed true to its original design using rows and columns and cells to store information. So historically, engineers have gravitated towards Excel for engineering calculations. There are several factors that contribute to why this happened. First and foremost, Excel is readily available. It's easily accessible, it's on every engineer's desktop, and as being part of Microsoft Office Suite, it's ubiquitous throughout organizations. On top of that, work can be shared and distributed without any additional custom software installed. So it really became a pervasive presence within engineering. As engineers, we have many requirements for how we do our work. And we have many requirements for applications and software that we use. So in this case, the question that we have to ask ourselves as engineers is whether or not the convenience choice is really the best choice. Does the convenient choice really truly meet our needs? And whether the convenient choice is in fact the right choice for what we need to do. So in contrast to the spreadsheet, our approach here at PTC to calculations with PTC Mathcad is entirely focused on the needs of engineers. We feel that we have a very good understanding of what engineers need. We need an application that is purposely designed for engineering math from the ground up. That changes everything. We need transparency and traceability in the calculations. We need reliable and precise calculations. We need capabilities for solving complex problems. And along with the math, there are other things that we need as well. We also need to write engineering design documents. We need to write reports. We need to write memos. We need to communicate our work. We need to show our work at design reviews. So it's not just about the math. It's about the math and then everything else that goes around it. Most of all, we especially want to be confident in the work that we do. So when we work within an environment that's specifically architected for engineers, we actually become better engineers. We're able to work within a natural environment, and that in turn leads to more creative problem solving. We can spend more time focusing on the actual engineering problems and the engineering calculations that we need to do, rather than spending that time figuring out how to force calculations into predefined structures or force calculations into cells in a spreadsheet. So rather than spending time trying to conform to a structure, we can spend that time doing real engineering work. So when we use a tool or an application that was custom built for the needs of engineers, that's naturally going to lead us to do better engineering and to be more confident in the work that we do. So we've been talking a lot about what engineers need and why it's imperative that we choose the right tool for the job. It's important to understand the fundamental difference between using Mathcad and Excel for calculations. On the left-hand side here, we see a formula written that calculates mechanical energy in Excel. On the right-hand side, we see the exact same formula written in Mathcad. So in looking at both of these, we can see that they are quite different from one another. We can make some observations. So on the left side, the Excel representation, it's difficult to decipher. It's very difficult to communicate what the actual calculation is. It's nearly impossible, it's very challenging to validate, and it doesn't incorporate engineering units. Engineering units are part of every calculation that we do as engineers. On the right-hand side, the Mathcad representation is the polar opposite of all of those things. The Mathcad representation is very clear. It uses natural math notation to communicate what the calculation is. Any engineer can look at this and can validate it, can understand it, can have a discussion around it, and it also incorporates engineering units. So in looking at these two equations side by side, it's very clear that the prime choice for doing the engineering math is Mathcad. So Mathcad, again, it was designed to meet the needs of engineers. So of course it's going to be better at representing the engineering math and doing the calculations. So on the other hand, Excel, as we've discussed, was created initially for accounting and finance purposes, and along with that for managing data. So Excel is excellent for data storage, data organization, data manipulation. It's perfect for managing your data. It was never architected for engineering math. It was never meant to be used for complex calculations or for communicating engineering knowledge. So Excel is the right tool for storing and managing data. Mathcad is the right tool for doing the engineering math on that data. So what does all of this mean? When it comes to engineering, we have to do calculations and we also have to work with data. Choosing to use Mathcad for the engineering math doesn't mean that we have to choose between Mathcad and Excel. We can use both. And we should use both to leverage the strengths of each application. We should use Excel for data management to store, organize, filter, sort, and present data. We should use Mathcad to perform calculations with that data and to incorporate the data into system models and analysis. These are not mutually exclusive applications. There's no reason to feel like it has to be one or the other. Use them both, use them for their purpose, and use them together to get the best of both worlds. So let's take a quick look at what using Mathcad and Excel together looks like. So here we are in Mathcad Prime. We're going to take a look at two approaches that we can use to use Mathcad and Excel together. The two approaches that we can use are listed here. The first one involves importing data dynamically from Excel into Mathcad. That's done with the READEXCEL function. And if we go up to the ribbon on the Input-Output tab, we can see a button here called READEXCEL. So that's the button that we'll use to implement the READEXCEL function. And again, that brings data in dynamically. It maintains a link to the source Excel data. If that Excel data changes, then Mathcad will update accordingly with the latest set of data coming from Excel. The second approach is through embedding an Excel spreadsheet inside the Mathcad worksheet. So this is called the Excel component. And on the ribbon, this is next to the READEXCEL button here. Just to the right of that, we have a button called the Excel component. So the Excel component will actually embed a spreadsheet inside the Mathcad document. And with that, we have configurable inputs and outputs. So we can configure inputs from Mathcad to Excel, and we can configure outputs from Excel back to Mathcad. And we have the full functionality of Excel available on that spreadsheet. So let's go ahead and scroll down. And we can take a quick look at how each of these work, and then we'll look at a couple of examples. So this READEXCEL button or READEXCEL function, that is inserted through the button here on the ribbon. I'm going to click on this button, and when I do that, we see a browser. So this is where we can browse for our Excel file. So I'm just going to browse for a data file that I have. this one here, ZFA. I'm going to click open, and now we can preview the data. So we can see more of the data if we want to. By default, all of the data is selected. And if we want to import a subset of the data, we'll just adjust the range with these columns and rows fields here. But by default, all of the data is selected. And we'll also see all of our tabs in Excel. So this one happens to have a tab called Inputs. It has two more generic tabs, and so we would select the tab that we want. So when we click Insert, this puts the READEXCEL function into the Mathcad worksheet, along with the path to the data file and the range that we wish to import. So we're importing from the Inputs tab, and the range is A1 to B9. Now, this READEXCEL function is also listed under the functions. If we go to the functions in Mathcad here, and we look at the file access functions, READEXCEL is about halfway down the list. Here it is. That is effectively the function that is being used. We have a button so that we can avoid all of this typing. So by using the button, we're able to import the data without having to type the full path and the sheet and the range and all of that. Now, in order to use this data, we have to assign it to a variable. So we'll just assign it to a variable called FA. This is force area data, maybe FA data. And then we can view the data. So it's two columns. It looks exactly like we expect it to look. If we don't want to display all of the data, then we can control how much or how little of the data we actually choose to view. And so there it is, FA data. You can see that we have headers on the columns. Force has units of kips, area has units of inches squared. So of course, when we import this data into Mathcad, we'll definitely want to take advantage of the units intelligence in Mathcad to assign units to those two column vectors before we use the data in calculations. So that's the READEXCEL function. So the second approach to using Mathcad and Excel together is through the Excel component. So let's go ahead and look at the second approach to using Mathcad and Excel together. I'm going to scroll down just so we have some more room to work with. And we're going to look at the Excel component. So now the Excel component will actually embed an Excel spreadsheet inside the Mathcad document. So to do that, we're going to go here to the Input-Output tab and go to the Excel component. We're going to click on the Excel component, and it will insert an Excel spreadsheet inside the Mathcad document. So we can double click on this spreadsheet to activate Excel. So this is an empty spreadsheet. We haven't done anything yet. We can create a spreadsheet from scratch here if we'd like to do that. We can also open an existing spreadsheet. If we just put some numbers in here, we can see that those numbers will come back into the Mathcad view of the spreadsheet. So there's the spreadsheet that we just created. So in order to use this Excel object, we can configure inputs to the spreadsheet and outputs from the spreadsheet. So we have full interoperability with the Excel spreadsheet. What we're going to do very quickly is define two vectors that we'll send into the Excel spreadsheet. So I'm going to define a vector alpha and just create a 3x1 vector. And I'll also create a vector called beta and create also a 3x1 vector. We're going to write those two vectors into this Excel spreadsheet. So in the input section, we can say starting at A1, we want to write in this vector alpha. And likewise, we can say starting at B1, we want to write in this vector beta. So that writes the data into Excel. So now we've just populated our Excel spreadsheet with alpha and beta. So let's double click, let's activate the spreadsheet. We'll get rid of this 44 in column C. Any formatting that we wish to apply to the spreadsheet will be viewable in the Mathcad document. And so let's go ahead and close that and come back into Mathcad. And last, let's do a calculation in Excel. So again, we'll activate the spreadsheet. We'll go into column C, and maybe we'll just do something very, very simplistic here. And we'll apply that. And maybe we want to highlight it, and we can close. So coming back into the Mathcad view, there we have our spreadsheet, and now in the output section, let's read those highlighted values out. So in the output section, we're going to read out from C1 to C3, that vector there, and we're going to assign it to a variable called gamma. Coming out of the spreadsheet, we can type gamma equals. So let's go back up to alpha and beta and make a change. We can also collapse the inputs. We can collapse the outputs. We can resize this so it looks exactly the way that we want it to look. And let's just take a look at what happens if we change beta. We'll change the 700 to 900. We'll hit enter. Beta goes into the spreadsheet. Excel calculates and gamma comes out. And so that's how Mathcad and Excel work together using this Excel component. Okay. All right, so we're going to hop over to this frame calc document here. This is a frame analysis on an automotive frame. What this Mathcad worksheet does is read Excel data and then use that data for calculations such as shear force, shear stress, bending moments, and so on for the member data of the frame. So all of the member data for this frame is stored in Excel, and we can look at it. So this is the Excel spreadsheet. This is the data, all of the member data for different parts of this frame. And you can see there's 3 sheets here at the bottom, 3 tabs. There's a summary tab, a charts tab, a calculations tab. So we're really interested in this summary tab here, all of this data. So we have some loading stresses, we have some distances. So let's go ahead and come back into the Mathcad document here. So there are 5 sections. Okay, the first section is where we input the data from Excel. Then we have the calculations for the forces and stresses, slopes and deflections, some configuration for the charts, and then finally the plots. So we're really going to concern ourselves with the importing of the data and calculate some of these calculations here, and then the plots. I'm going to expand section 1, and we can see all of these READEXCEL functions. Again, this is from this button here. This is what we just did. So all of these READEXCEL functions are reading from that summary tab certain ranges and then assigning appropriate units. So we have all of the data being read into different variables. We can look at the position vector, and we can look at that in units of millimeters. Maybe we also want to look at the loading vector, units of newtons. And so that's the data coming in from Excel. So let's collapse this back down and look at some of the calculations. So these are the equations that are used to calculate shear force, shear stress, the bending moments. Once again, as we've talked about before, these are very transparent, they're very clear, there's no confusion, no ambiguity around what the engineering math is. So we have all of these functions for stress and force and moments. Let's keep going. And the bending stresses on the top and bottom surfaces. Let's keep going to this plotting section. So I'm going to expand the plotting section, and then we can take a look at the plots. Okay, so there's the plot for shear force, and we can scroll down and we can see some of the additional plots for stress and the moments. Now, the important thing to remember here is that all of these plots are being created with data coming from Excel. So again, we're not storing the data in Mathcad. In this case, we are not storing the data in Mathcad. We're leaving the data in Excel. That's where it belongs in this particular case. We're importing it, we're reading it, we're calculating with it, and we're creating plots with that data. If that data changes, then all of these plots will update. We don't have to import it again. We just have to run the Mathcad worksheet again, recalculate, and all of these plots will update. So let's take a look at another worksheet here, this I-beam selector. So this Mathcad worksheet uses the second approach we talked about, the embedding of an Excel spreadsheet inside a Mathcad worksheet with inputs and outputs. So this is a beam deflection analysis, and we have an Excel spreadsheet that has a large amount of beam data in it. And on the very left are the beam IDs. And then for each beam, we have multiple properties. So this is actually an Excel spreadsheet embedded in Mathcad. It was put in here using this Excel component. So if we double click on this, we're going to activate Excel and we'll be able to see the spreadsheet that stores all of this beam data. So let's just double click here. So here's the spreadsheet. Okay, and you can see here all of the beams are on the left, all of the properties going across the rows. And if we scroll down, we'll see that there are quite a few beams here. And we'll go back up. And so what we can do is just close this. We don't have to have that open. So we're back here in Mathcad. Now, we don't have to display all of the beam data. We can control how much of that data we want to display. So what we're going to do is select a beam. And for that beam, we're going to do this beam analysis, this beam deflection. So let's scroll down a little bit. And we have this variable here for the ID. So the current selected beam is beam ID 267147. And then we use a matching function to find that beam in the spreadsheet and then map properties for the selected beam to variables in the Mathcad worksheet. If we scroll down, we can look at the properties on the right-hand side here. These are properties that are getting automatically mapped from the Excel beam data into Mathcad variables. So watch those numbers and we'll change the ID of the beam. So we can change the ID of the beam. Let's say instead of 267147, we'll just say we want to read properties for beam 292.176. I'm going to hit enter. When I hit enter, watch these properties on the right-hand side. Everything changes. Everything changes because now we've selected a different beam and we're going to map properties for the new beam. And then these properties are used for the analysis. So we can scroll down and take a look at what's happening here with the calculations. Here we have the plot of the shear, the moment for the selected beam, and maybe more interesting is the deflection curve here. So if we look at this deflection curve, we can see it there. So perhaps what we should do is go to the top, select a different beam, come and look at this deflection curve. So we'll go back up here and select a different beam. So we could probably just go back to the beam that we had before, 267134. And now let's scroll down and again look at that deflection curve. And we can see that it's changed. So that's how we embed Excel inside Mathcad. So two very powerful approaches to using Excel and Mathcad together. The READEXCEL function, which does not store any Excel data in Mathcad, but remains linked, and the Excel component, which lets you embed Excel inside Mathcad with configurable inputs and outputs, along with the full functionality of Excel available. So again, if we go back up to the top here and activate our spreadsheet, maybe we want to do some simple formatting. Maybe we just want to change the color of that, make a couple of these things bold. We could do that too. If we come out of here, we're going to close, land back here in Mathcad, and we can see the changes that we just made. So we've actually covered quite a bit of information today as far as how to use Mathcad and Excel together and why you would want to use Mathcad and Excel together. In closing, I'd like to encourage you to think about whether you're doing your best engineering work by using the right applications. Think about how easy it is for mistakes to creep into spreadsheets. Think about the amount of time you might spend reverse engineering a colleague's spreadsheet, or even reverse engineering your own spreadsheet. Dr. Alan Stevens, mathematical modeling and simulation specialist at Rolls-Royce, said, "Talented engineers are using Excel and getting serious errors of which they're simply not aware, and errors build up more rapidly than you might expect." That is so true. Thank you, Dr. Stevens, for your quote. So remember the distinctions we talked about between Mathcad and Excel. Remember to use Mathcad and Excel together to optimize your engineering calculation workflow and get the best of both worlds.